What's up, guys? So this video is about decimal and binary number IP address conversion. My goal is to teach you how to convert a dotted decimal formatted IP address like this one into its 32-bit binary number representation shown right here. And you also learn how to do the opposite in converting a 32-bit binary IP address like this one into its dotted decimal representation. So first, let's review a little bit about exactly what an IP address is. IP stands for Internet Protocol and is the main protocol responsible for routing data packets across networks like the Internet. So a protocol is a set of rules, and Internet Protocol is the primary set of rules that governs the exchange and transmission of data between computers or devices on separate networks. The IP address is a 32-bit number used to uniquely identify different networks as well as the devices or computers within those networks, and it has two separate parts. The network ID portion identifies the network where the computer lives, and the host ID portion identifies the computer on that actual network. So looking at the numbers of the example IP address shown below, the first portion of the IP address, the first three blue numbers, uniquely identify the network on which the computer sits, and the host portion, the green number, the last number, the 1, identify the actual computer on that network. So in this example, the 192.168.10 uniquely identify the network, and the 1 identifies the actual computer on that network. It is important to note that it doesn't always have to be that way. The network portion of the address could be just the first two numbers, the 192 and the 168, and the host ID portion is now the last two numbers, the 10 and the 1. It is, however, standard that the network ID portion is before the host ID portion. You have to identify the network first before you can. So let's review some of the rules of an IP address. As I said, it's a 32-bit long number divided into 4 8-bit octets. And an octet is just an 8-bit binary number representing a single decimal number from 0 to 255. So 4 8-bit numbers multiplied together, you can see how you get that 32 bits, with each bit represented by either a 1 or a 0. An example of that 32-bit binary number is shown below. Now each bit in that 32-bit sequence is represented by either a 1 or a 0, and only 1s and 0s. It can't be any other number. So that long 32-bit sequence of 1s and 0s is how a computer communicates and understands an IP address. But for people like you and me, it's not that easy to communicate that way. So for our sake, that number is represented in dotted decimal format, which is just those 4 numbers for an IP address separated by decimal points. And that's typically how we view an IP address. So even though an IP address is a 32-bit binary number, we normally don't communicate it that way. We communicate it in dotted decimal notation, which is just that long binary number with each 8 binary bit sequence representing a single number from 0 to 255. So given this dotted decimal formatted IP address, how do we convert it into binary? How do we convert it into those 4 8-bit octets? Well, we know each of those numbers represents one 8-bit octet. 1 octet, 2 octets, 3 octets, 4 octets. So to figure this out, we need to talk a little bit more about binary numbers and trying to understand exactly where they come from. So I want to start off by trying to explain the anatomy of a typical number. So let's take a look at this number. This number is obviously 5,349. It has 4 digits, which means it has 4 places. It has a ones place, tens place, hundreds place, and thousands place. And it has an individual number in each of those places. So in the ones place it has a 9, in the tens place it has a 4, in the hundred place it has a 3, in the thousands place it has a 5. If we multiply each of those numbers by their place value, so 9 times 1, 4 times 10, 3 times 100, and 5 times 1,000, and sum those numbers together, we get the original number of 5,349. But where exactly do those column values come from? That ones, tens, hundreds, and thousands. Let's go over that. Essentially, these numbers come from exponential numbers with a base 10. Starting out with 10 raised to the 0th power, which results in a 1, or the ones place, followed by 10 raised to the 1st power, which comes out to be 10, or the tens place, followed by 10 to the 2nd power, which comes out to be 100, or the hundreds place, and so on. And for this table, I only went up to the millions place, or 10 raised to the 6th power, but you can obviously go a lot farther than that to the billions and the trillions and whatnot. But what the base 10 means, the base of the exponential number, is that for each column you can have exactly one of 10 numbers that can go into each of these places. A single number choice from 0 to 9, that's 10 numbers. So now that we've reviewed that number system that we are all pretty familiar with, let's talk about the binary number system. So how exactly long 32-bit 4-octet sequences of ones and zeros comes out to represent normal numbers. So a binary number is very similar to a base 10 number, except it instead has a base of 2 for its exponential number instead of a base of 10. So similar to base 10 in having 10 number choices for each column, 0 to 9, for base 2 there are just 2 number choices for each column. It's either a 0 or a 1. In the table to the right, I have shown the result of each exponent from 2 to the 0th power to 2 to the 7th power. While it can obviously go far beyond 2 to the 7th power, for our purposes of understanding 8-bit octets, which represent only numbers from 0 to 255, we only have to go up to 2 to the 7th power, which column's value is 128. And each of those columns represents a single bit for the 32-bit IP address. So let's begin by converting the 8-bit binary number shown, or this single octet, into a decimal formatted number. To do this, simply place each of the numbers into the table as they appear and add up the numbers in each of the columns that contain a 1. Remember, we talked about how 1 means on and 0 means off. So adding up each of those numbers in that table that contain the 1, that would be 128 plus 16 plus 1, which equals the number 145. So that single octet, that 8-bit binary number of 1, 0, 0, 1, 0, 0, 0, 1 is the same thing as 145. Now let's convert an entire 32-bit binary number IP address into dotted decimal format. The binary numbers for each of the 4 octets are shown. To convert the first number, we simply place each of the numbers into the base 2 table, binary table, and sum up the columns that contain 1. And we already did this one. Now let's take the next number and put it into our base 2 table. And for this one, the only column that had a 1 in it was the 32 column, so the total is just 32. Now let's put the next number into the table. Sum up all the columns with 1s. So 32 plus 16 plus 8 plus 2 plus 1 is equal to 59. So this 8-bit sequence represents 59. And lastly, sum up all the columns with 1s, and the number is 16 plus 8, which is 24. So after doing that, you can see that the dotted decimal formatted IP address that resulted from the 32-bit sequence of 1s and 0s is 145.32 0.59.24. Next, I want to talk about converting a number in base 10 decimal format into a base 2 binary number format. For IP version 4 addresses, these numbers will range from 0 to 255, and each number will be represented with 8 bits, or an 8-number sequence of 1s and 0s. So let's take this 192 number and convert it into a. The first thing you want to do is to look for the highest column value number from the base 2 table shown below that goes into the number 192 without going over it. In this case, that number would be 128. So you take the original 192 and subtract 128 to get 64, and then you make sure to mark the 128 column with a 1, which indicates on status. The next thing you want to do is to find the next highest number from the base 2 table that goes into 64 without going over. And in this case, that number is simply 64. So you subtract the 64 column number shown in blue from the 64 number that you got from subtracting 128 by 92 to get 0. You place a 1 in the 64 column to show the on status. And since the final number is now 0, you can place a 0 in all the other columns because none of those base 2 column numbers can go into 0. So the 8-bit or 8-number sequence that represents the number 192 is 1, 1, 0, 0, 0, 0, 0, 0. And you can check that you are correct by doing what we did previously, which is adding up all the columns that contain 1s. So in this case, that would be 128 plus 64, which in fact does equal 192. So going back to our original problem of trying to figure out exactly how to write this IP address in binary format, well, we now have the tools to answer this question. We already calculated the 8-bit number for 192, so we can just skip over that one. Let's look at 168 now. First, find the highest number that goes into 168 without going over, and that number would be 128. So subtract 168 minus 128 to get 40, and place a 1 in that 128 column. Then find the next highest number that goes into 40. In this case, it would be 32, and subtract it from 40 to get 8. Then find the next highest number that goes into 8, which is the column 8. Subtract it to get 0. And then place zeros in all the unused columns, and you can see that your final binary number is 10101000. Again, adding up all the columns with the 1s, you can see that you will get 168. 128 plus 32 plus 8 is 168. Next we got 59. First highest number is 32, so you subtract it to get 27. Next highest number is 16, subtract it to get 11. Next highest number is 8, subtract it to get 3. Next highest number is 2, subtract it to get 1. And the next highest number is 1, and subtract it to get 0. Placing 1s in all of those columns that we used. And adding up all of the columns with 1s, you can check and see that it indeed does equal 59. 32 plus 16 plus 8 plus 2 plus 1. And finally, 24. 24, first column is 16, minus 16 is equal to 8. Next column would be 8, so 8 minus 8 is 0. So placing 1s in both of those used columns and 0s in all the other unused columns, we get our 8-bit binary number. 16 plus 8 does equal 24. So now you guys know exactly how to convert a dotted decimal formatted IP address into its 32-bit binary number format or representation. So now that you understand exactly how to convert base 10 decimal numbers to binary, as well as how to convert binary numbers back to base 10 decimal numbers, you have an important tool learned. This is a very important tool for understanding IP addresses as well as understanding some other fundamental networking concepts like classless interdomain routing, subnetting and subnet masks, and variable length subnet masks. Goodbye, guys. Thank you.